And I'm back one more time. So if you notice in my calculator, I typed 2 minus 1 instead of 2 minus 4. So let me go ahead and change that. I probably should have just done it by calculating it by hand. So this is 3. But that actually allowed me to notice that there wasn't symmetry in my graph. So when I went back to plug it in, okay, so now we have the correct numbers in our calculator, 2 minus 4 in parentheses squared minus 1. Now we can plug in a 3. So we have 3 minus 4 in parentheses squared, so we've got a 0 here. And then when we plug in 5, we got the 0 again, and then we got the 3. So now our graph is making sense. Okay, so we can go ahead and graph these points and create our parabola. So we have a point at 2, 3. We have a point at 3, 0, 4, -1, 5, 0, and 6, 3. And then we'll go ahead and connect them with the curve. And then we'll identify our domain and range. Remember, our domain is all real numbers, and our range would be y is greater than or equal to, since it's a down or upward facing parabola, our lowest value for y is -1. Okay, and on to our last page, some projectile motion questions. Okay. So we have a rocket being launched from a platform. The height h is modeled by this equation that we have here, and our t is time in seconds here on our y or x-axis. So what we are looking for is the maximum height, and then we're going to draw a sketch of that parabola as well. Let's first identify the a, the b, and the c at 45. Okay. So we do know that because a is negative 15, I know that it's going to be a downward facing parabola. Okay. And let's first identify or figure out where our maximum height is for the rocket. So our maximum height is negative b, and b is 30, all over 2a. So 2 and an a is negative 15. So this is going to give us a negative 30 divided by a negative 30, which is 1. So the time is 1 second, but we actually need to know the maximum height. So we need to plug 1 back into this equation so we can get a coordinate point for this. So that'll help us give us a sketch. All right, so let's plug in 1. So we have height now equals negative 15 with 1 squared plus 30 multiplied with 1 plus 45. We'll just do this simplified in our calculator. We know 1 squared is just 1, so this is going to be negative 15. 30 times 1 is just 30. So plus 30 plus 45, and this is going to simplify to 60. So our height is 60. And I don't think we said this, but it should be height in feet. So let's say at 1 second, our height was 60 feet. And then if we wanted another point just for the purposes of the sketch, on my y-axis here, if I plug in 0 for time, put a 0 here, put a 0 here, I'd get a point at 45. So we also have one other data point of 0, 45. So it might be nice to scale our graph by, we could do 15s, 15, 30, 45, 60. So we start out at 0, 45. So I'll put a point here. We then have our max height at 160 here, and then we just have our rough sketch of the parabola. And you can get an even more accurate sketch of where the ending point is if you use the quadratic formula to solve for where it crosses the x-axis as well. Okay. So for the purpose of this question, we're just looking for the maximum height and a sketch. So that would be enough for now. And then the rocket reaches a max height of 60 feet after 1 second. And we found this by, I'll just kind of talk you through it, but we found this by figuring out the vertex of our parabola and plugging in negative b over 2a and substituting 1 second in to our original equation. Please let us know if you have any questions during office hours. We are here for you. Bye.